The Pythagorean theorem is a very useful application in coordinate geometry. It's very useful in many things like construction, architecture, and many, many more applications. We can find distance on a coordinate plane. For example, the distance of this line goes from here to here, and we count the spaces. That's important, the spaces between the lines. So I'm going to count over 1, 2, 3, 4. I see that that line is 4 units long. So we can find the distance between 2 points. First, we're going to graph these 2 points. Here's -3, so I go over -3 and then down 5. 1, 2, 3, 4, 5. There's my point. And then the second point is at 4. 1, 2, 3, 4 over to the right, and +2, 1, 2. And we connect that, and we can find the distance of that line, but not like we did on the other one, because we can't just count straight units. All of those, it's a diagonal. So how could we apply the Pythagorean theorem here? Okay, well, we're going to take and create a triangle out of those 2 points. So I'm going to travel till I am right underneath the other one and connect like that. So now I can count. I have a right triangle, and I can apply the Pythagorean theorem for a squared. Here, this is A, this is B, and the one across from the right angle is the hypotenuse, C. So I have A squared plus B squared equals C squared. When I count the lengths of the 2 legs, I find them to be 7 and 7. So we're going to plug that into the Pythagorean theorem for 7 squared plus 7 squared equals C squared. Using the calculator, I type in 7 squared plus 7 squared, then hit the equal sign, and it is 98. Now that's equal to C squared, which is not what we're going for. We need C all by itself. So the opposite of squaring is square rooting. So we square root both sides, and we get C by itself, and then square root the 98. Round to the 10th, and it is 9.9. So the length of this red line over here is 9.9 units. I would like to point out that we could have made our triangle go over here this way, and we still would have the same result. Counting, we still get our legs to be 7 and 7. Pause the video and find the link between these 2 ordered pairs. Remember that you need to first graph them, and then you have to create a triangle with that line so that you can apply the Pythagorean theorem. Okay, pause it and do this on your handout now. After creating your triangle on your coordinate system, you count to see how long the legs are, and then we use those as your A and B on your Pythagorean theorem. So you have 4 squared plus 5 squared. Now you can type that into your calculator all at the same time, hit equals, and it's 41. Now that equals C squared, but we need to get C all by itself. So the opposite or inverse of squaring a number is square rooting a number. So we square root both sides of the equal sign to get C by itself, and the square root of 41 rounded to the nearest tenth is 6 4/10. So that's the distance of the hypotenuse of this triangle, which is the distance of our line. And it makes sense. Let's just check. We have 4 for one side, 5 for the other, and 6 4/10. Yeah, it looks good. Find the distance between P and Q on this coordinate system. So in order to do that, you can create the triangle right there, and then use the Pythagorean theorem. So pause the video and do this problem. So first you need to create a triangle out of it. So that is going to be the 2 legs, the A and the B. And then you're counting, and you want to count the spaces between the dots. So this would be 1, 2, and so on. And you count all of those, you'll find it to be 11. For that leg, count this, and you'll get 6. Put that into your Pythagorean theorem as the legs. A squared plus or 6 squared plus 11 squared is c squared. And you should get 157. That's equal to c squared. Again, we have to undo the squaring, so we're going to square root both sides of the equal sign. And rounded to the nearest tenth, it is 12 and 5/10, which is the distance between the point P and the point Q. Find the distance between C and D on this one. Remember that when you are using the Pythagorean theorem, it's very important to write out those steps as part of an equation. So you're getting very good at solving algebraic equations, as well as using the Pythagorean theorem. Okay, pause the video and do this problem. So when you make your triangle out of it, and then count to find the length of the two legs. So we're counting the spaces between the dots. One of the legs will be a 2 for 2 squared, and the other leg is 7 squared. That's going to equal c squared. Okay, use what you know about solving equations, and we would get 53 equals c squared. But again, that's not c. We want c just by itself, so we square root both sides. And the square root of 53, rounded to the nearest tenth, is 7 3/10. And then check to make sure if that looks right, if that would make sense on this triangle. We know it's got to be the longest leg, or not leg, sorry, the longest side, because it's the hypotenuse. So we'd have 2 for the short one, 7 for the next leg, and for the hypotenuse, a 7 3/10. And it does look like that would be right.